Hi everyone, let's look now how radians work with arc segments and sectors. Now from earlier exercises we know that an arc length is theta degrees divided by 360 times 2 pi r, which is just a proportion multiplied by the circumference. Now if we split this first expression here into two parts, so theta divided by 360 is the same as theta on 1 times 1 on 360. I've split this because it makes it easier to work down here with it, but that's the basic arc length formula there. Now in the last recording we learnt that theta degrees is equal to 180 times theta radians divided by pi. There's a little explanation of it here, but I might skip that since we've already been through it. And all I've done is I've taken this equation here and I've substituted it into where theta is here. So you can see there's theta on 1, which is just that, multiplied by 1 on 360 times by 2 pi r. Now I've split this because this is much easier to work with than substituting it directly into this equation. That fraction's getting a bit nasty to understand what the hell's going on. So once we have this, we can simplify it. 180 on 360 simplifies down to a half. This pi will cancel out with this pi over here, and we get left with 2 radians theta radians. That 2 will then cancel out with this 2 here, and funnily enough we're just left with the radius times by theta radians. And in fact this arc length formula quite simply is the radius times by theta in radians when we're working in radians. Similarly, arc length simplifies down to half times the radius squared times theta radians, and the minus segment area formula simplifies down to half r squared. Theta radians take sine theta radians. I might just put this little r up here. It may not be strictly the correct notation, but it does make it a lot easier to understand. So all these thetas are theta in radians. So if we're looking for the minor sector area, which is the area inside this sector, and we know that that angle there is 1.4 radians, we just go half times the radius, which is 16 squared, times by radians, 1.4 in this case, the angle, and we get 179.2 centimeters squared. So this area here, if we have this radius and this angle, is 179.2 centimeters. If we're looking for the minor segment area, which remember is relatively difficult to do in the last exercise where we worked on minor segment areas, the formula is now quite simple. It's just half r squared, half times 21, brackets 1.8, the angle in radians, take sine of 1.8, whatever that is in your calculator, and you get an answer of 182.2 centimeters squared. That gives you this little area here that we're looking for. Now make sure that your calculator is in radians mode, or it will not work. And preferably when you're finished, make sure that you put it back into the mode you use most. If you're working in degrees, leave it in degrees mode. If you're working most in radians, leave it in radians mode. And that takes a rather complicated little exercise and makes it quite simple. So I would now attempt exercise 2C and have a go, and you'll see that it's not really as confusing as it at first seems. Thank you, everyone.